This is the Chapter 5, Section 4, Skill 3, Example 1. This is an application of that integral as a net change, where we're accumulating things and talking about what that accumulation represents. So we're told at a certain height a tree trunk has a circular cross-section. The radius of that cross-section grows at a rate modeled by this function. So what we have been given is dr dt measured in centimeters per year, and the inputs are years. So if we look at part A, it says write an expression involving an integral for the radius on this closed interval, and then use your expression to find r of 3. So notice that we have the derivative of the radius, and if we continue to read, it tells us that at time equals 0 the radius is 6. So that means we got a point on the radius curve. So we can use the derivative and the point to write an expression for the radius at any time, and it will be the radius we begin with plus the accumulation from 0 up to a time on that dr dt, or r prime function. So now if we want to find r of 3, that means we'll have 6 plus the accumulation from 0 to 3 on that r prime. So on my calculator, I have put the r prime into y1 using an x. So on my home screen now, I'm going to do 6 plus the accumulation of that y1 of x with respect to x from 0 to 3. And I will end up with 6.6108 or you could round it to 6.611, and then it says use your expression to find it. It didn't tell us to put the units on, but just to be safe, I'm going to think about what that accumulation will represent. Notice that the rate at which it's growing is measured in centimeters per year, so my height was centimeters per year and my width was years. So when I multiply that together, I end up with centimeters. If we look at part B, it says find the rate at which the cross-sectional area is increasing at time equals 3 years. So in order to get the area, notice that it is a circle. The area of a circle is pi times that radius function squared. So I want the rate at which it is growing. So that means I need to take the derivative with respect to time of that a. If I do that on the other side, I will move through the pi, then I'll hit the power rule, leave the inside unchanged, and then multiply by the derivative of the inside. We're interested in knowing what that dA dt will be when time is 3. So that means I'm going to plug 3 into r and then multiply by r prime of 3. Now notice we already figured out r of 3 in the original problem. So what we need to do on our calculators is do pi times 2 of these times r prime, which is stored in y1, times 3. So if I do that on my calculator, I will have pi times 2 times that number I just computed times y1 of 3. Hit enter. We end up with 8.858. And let's think about what the units of area's rate might be. We know the area is measured in square length units, and since we're measuring the radius in centimeters, that means the area would be measured in centimeters squared. And when we take the derivative with respect to time, that's going to put a year unit on the bottom. So centimeters squared per year. Now if we continue on to part C, it says we want to evaluate the accumulation. Let me just scoot this up here. Evaluate the accumulation from 0 to 3 of a prime with respect to t. and then interpret what that means. So if we think about what this symbol tells us, it says, what did I take the derivative of with respect to time that gave me an a prime? And the answer to that question would be a evaluated from 0 to 3. So that's going to be the cross-sectional area at 3 minus the cross-sectional area at 0. Well, we know that the area's cross-section is 8.858 at time equals 3, and we know when time was 0 that our radius was 6. So the area at time 0 would be a pi times that 6 squared. So on my calculator, I can do, oh, excuse me, that is incorrect. I was looking at the rate. We need a pi times the radius squared at 3. So that's going to be, let me get rid of this. That's going to be a pi times a 6.6108 squared minus that 36 pi. So on the calculator, I will do a pi times that first radius at time equals 3, which we computed already, so we can go grab it up there, hit enter and square it, minus 36 pi, diamond enter. We end up with 24.201. Now we want to know what the units are. So the units are going to be given to us by an accumulation of a centimeter squared per year over years. So we end up with centimeters squared because we'd multiply this unit times the years, and the years would cancel. So we end up with the change in the surface area, or the cross-sectional area, over that 3-year period. So what does it mean? It means the cross-sectional area increased 24.201 centimeters squared in the time period from t equals 0 to t equals 3 years.